All right, I think we can go ahead and get started here. So I'm Chris, this is John. We're here to talk a little bit about HIPAA compliance in the cloud for Hadoop. John and I met probably around a year ago. So we were really excited last year. Our Hadoop managed service, it passed its FedRAMP audit, which was great news because it made it HIPAA eligible. So we got on stage, we announced it at one of our summits, and instantly we started getting customers and insurance companies and these big providers are like, this is fantastic. How do we actually configure Hadoop, to be compliant, to be HIPAA compliant in the cloud? And so I call up John, who's the product manager of our Hadoop service, and I say, yeah, hey, John, how do we do this? And he's kind of like, oh, I don't know, but don't worry. We got a healthcare guy now. He knows how to do this stuff. I was like, oh, great. And then I realized, oh, wait, that's me. So then we sort of started working together, and a lot of the struggles that we went through to figure out how you actually make a HIPAA-compliant Hadoop offering in the cloud. We're going to talk a little bit through that today. Now, what we can tell you here is, yes, we're from Amazon. We initially did this for our version, our distribution of Hadoop. But most of what we're going to talk about, it really does cross both cloud providers and a lot of the gotchas with Hadoop itself. It's kind of the open source issues, and so even if you're on-prem, probably a lot of what we're talking about will still be applicable to you regardless if you're trying to meet HIPAA compliance, regardless of where you are. If you're on-prem, Google, Microsoft, or on the moon, its HIPAA controls are still HIPAA controls. So little background on who I am first. So I got my start close to 12 years ago. I initially started working as a biostatistics application developer underneath an NCI cooperative group. And I was doing a lot of distributed systems programming and more or less building cloud architectures before we even had that fun buzzword of the cloud. I think we just called it distributed systems programming. But through that position, I got a lot of interest in what the biostatisticians were actually doing on these phase 3 clinical trials. What was the actual research? So I went back to school, got an MPH in biostatistics, and I took that combination of computer science and statistics to Memorial Sloan Kettering Cancer Center, where I spent some time there managing a data science team. In the last couple years, I've been at Amazon Web Services, where I'm a healthcare and life science solutions architect. And what that actually means is I help a lot of our customers in the healthcare and life science industry either build or move their applications onto the AWS platform. And so you'll see there's a lot of interest in this space. You're going to see household names up there like J&J, but then all the way to a lot of these niche players like BioTeam, who are just doing a lot of interesting stuff in the healthcare space, especially around big data and analytics, because it's a great spot to move to the cloud. It's a great workload to move to the cloud. So this is a common trend that we're seeing, is that healthcare is making a big move to the cloud. It's kind of an industry that's just ripe for kind of the next technology innovations, and it's moving to the cloud very fast. These stats all come from a HIMSS survey that was done, but basically what was found is 83% of healthcare organizations are using cloud services and are expected to grow in the future. The most frequent uses today include hosting clinical applications and/or data, and the most common model seen is software as a service. And then nearly all the healthcare organizations presently using cloud services definitely plan to expand their use of cloud in the future. And I can tell you just from my personal experience, just starting a couple years back at AWS, every time I would meet with a customer or meet a new organization, the conversation was always, is this secure? Who owns the data? Is my data secure? How do you protect the data? And that conversation's really shifted. And it's no longer about are we going to the cloud? Does it make sense? It's not really an if question. It's now a when question of when are we going to the cloud? How fast can we get there? And what applications can we move first? And so a lot of what's driving that is a need to actually do a lot more collaboration across studies. So if you're not familiar, if you're a cancer patient, there's only about a 3% chance that you're going to actually end up on an innovative clinical trial where we're actually going to try new things. And we know that's a paradigm shift that has to happen. We have to start moving to more collaboration. Get bigger data sets across multiple institutions. So this is a really common architecture pattern that we're seeing through company after company. And if you're not familiar with most of the left-hand side of the slide here, don't worry too much about it because these are AWS architecture icons. But the general idea here is that you have your research center, and they have a back end up into the cloud, and that you can manage all of the permissions, the applications, who can do what, And then you have a lot of external researchers that now through the cloud can be anywhere in the world to start contributing back to your study and get access to their own data sets, control all the permissions with managed databases in the cloud, and take a lot of that IT heavy lifting out of building these global collaborative medical research platforms. And now the idea is, as you share all this data, you have it in this big object store in the cloud. And then instead of trying to take all that data back down and silo it once again to all these different organizations, what people are doing is they're just spinning up Hadoop clusters right in the cloud so you can start to analyze that data in the cloud without having to move it all around and giving people access to those Hadoop clusters, to a way to query that data. And so just a little disconnect in the cloud is you don't act, and this can happen on-prem too, but the cloud model, and again, across cloud providers, they all can pretty much do this, is you separate your storage from your compute in most situations. So instead of having to rely on that HDFS layer that's sitting there and you have compute spinning just to store data, you only spin up compute when you need to in the cloud, and you keep all your data in that very cheap object storage. And so that's just, there was a talk before this, if you want to know more about what I just talked about, there was a how to use object storage in the cloud with Hadoop. Right before this would be a good video to go look up. But that's the basic idea, is you leave your data very cheap in place, object store. You have separate compute that is up and spinning only for when you need it. And the other advantage of that is people can right-size their cluster. So if you're running a machine learning algorithm, you spin up a very compute-intensive cluster. You want interactive analytical queries, you spin up a memory-intensive cluster, and yet it's always the same source of data that everyone can point to. And so all of this stuff, it's really going to need to have, be HIPAA compliant across the board. But for what we're going to talk about today, we're going to focus in just on the Hadoop piece of this. And the two icons you see here is, it could be a Hortonworks distribution, Cloudera distribution, or it could be the Amazon EMR distribution. Everything pretty much is, a lot of what we're going to talk about is pretty generic to Hadoop itself. But just a real quick primer, just in case you haven't seen it, that icon for Amazon EMR, that stands for Elastic MapReduce, but it now does pretty much most of the applications that you're familiar with, Oozie, Spark, Hive, all that can be as a managed platform. So the same way you go on Amazon.com, buy whatever you want, you can do that with Hadoop clusters via Amazon Web Services and Amazon EMR. You can launch a cluster in a few minutes. It leverages a lot of that elasticity of the cloud, meaning you can have your cluster, and then you can scale it up, and then scale it back down as people, as the analytical or the workloads change. There's a lot of baked-in security features, and then you can pay for by the hour. So you can more or less rent time. And we also have something called a spot market, which means that if we have unused compute capacity, which at our scale as Amazon Web Services we almost always do, you can bid on that unused capacity for a much, much lower price than you would normally get, and get really cheap compute, which works well for a lot of these analytical workloads that you could just speed up if you can throw additional compute at it, if you can get it cheap. But again, a lot of the HIPAA controls, this is kind of the open, this is our version of the open source platform, but a lot of what we're talking about here, it's going to be relevant no matter which cloud platform you choose. And so why is HIPAA compliant such a hot, it really is a hot topic right now. And it's because it's important, first of all. With HIPAA, you have a lot of legal implications behind what you're trying to do. But then also, this is real patients, real patient data. We're trying to store a lot of unstructured notes about these patients, and that's a real person and their private information. We want to protect that, so it's very important to do that. But it's also kind of hard because of the way Hadoop is a distributed, disconnected platform. It's kind of funny, when we had TCP that got invented and the internet originally came out, everyone complained that there was no security built in or it was never a thought. And so now we have to do all these add-ons like HTTPS and go back and fix the internet to make it actually secure. And so you'd think we would have learned from that, but as we moved into big data, we really didn't. We kind of left security as an afterthought for so many of these new services, and so that's kind of, we're going back now and trying to piecemeal a lot of security in here. So real quick primer on HIPAA, if you're not familiar. These are just sort of a grab bag of things you probably want to know if you're going to be talking about how to secure an environment for HIPAA. So first of all, it is HIPAA with 2 A's, not 2 P's. That's a big giveaway to show that you're a newbie in the field if you've made that mistake. It is the Health Insurance Portability and Accountability Act. So it came around in 1996 under George W. Bush's administration, and it was really a law designed around claims processing, and that we needed to move the government to these electronic claim processing systems. But then there was this add-on that says, oh, we have to protect that information as well, and that's where HIPAA came from and a lot of the stuff you're seeing today. Now, in general, there's 4 main rules around HIPAA. There's the privacy rule, security rule, breach and notification rules, and enforcement rules. So the privacy rule, this is what protects you as a patient. These are the rules that are associated with what rights do you have to your own record, what is what's called protected health information. So if you see that term, PHI, protected health information, that means that you have to be HIPAA compliant on that. So, and what PHI is, it's a way to actually identify this person is associated with these medical records. Now, my first kind of best practice around PHI is I would always question whenever I work with my customers is, do you actually need PHI in your Hadoop system? Or do you actually need to have, if you're doing these big population health studies, do you really have to get into the actual identifiable information for somebody? Or can you put that into a separate service and then just put what's called the de-identified information into the Hadoop system to run your big scale analytics? So that's something you always want to keep in mind. And in general, there's 2 approaches to de-identifying PHI. The first is the safe harbor method, which is just, there's 18 different elements that they've identified on the HHS website you can go look at, and you can simply just take those out. So those are things like social, IP address, first name, last name, and it's pretty straightforward except when you get to element 18, and element 18 is kind of this general catch-all that is this vague thing that's kind of like, or anything else that might identify this person. And so that takes you down a lot of rabbit holes and a lot of talks with lawyers deciding, okay, is this identifiable, is this PHI? And so the second approach you can take is something called the statistical method, where you have basically statisticians that will come in and say, yes, I certify that this is de-identified data. You cannot track back to these people using these methods. And so those are just something that, things you should consider before you actually just start dumping a bunch of PHI into Hadoop, because maybe you can avoid some of these HIPAA headaches if you can do that. But again, there are ways to do PHI in Hadoop, so if you want to do that, by all means, there's ways to do it. The next rule was the security rule. The security rule is associated with, okay, what these systems that are actually protecting the PHI, these are the rules around those systems. Now, if you're thinking, oh, that's great, I can go up and look on HIPAA and this will tell me exactly what to do with my system, you're going to be a little disappointed when you go to the website and you're like, oh, okay, what do I do for network security? I should protect my network. And I think that's pretty much what it says. It says protect my network. I'm like, all right, not overly helpful. So advice I give to people when they're looking at, okay, what are these security controls I should consider? There's a NIST document. It's a subset of controls called, it's a subset of 853 and 866 document. And that actually aligns directly with the HHS's version of HIPAA. And so when customers want, well, where's my checklist? I tend to give them that NIST 866 controls and use that because you're not going to find a ton in the security rules themselves. And the next one is the scary part. It is the breach notification. This is why people are terrified of HIPAA, because breach notification rules, this means you actually have to report when someone has unauthorized access to what's called unsecured PHI. Generally, that means unencrypted, but there's some gotchas there. But in general, unencrypted PHI, you found someone that had unlawful access, you actually have to report that. There's legal implications, there's fines, what's called the ONC is going to come in and audit you, and then you're going to have to basically pay for a lot of people to go check their credit scores and things like that. And a lot of times you end up on the front of newspapers too for these breach notifications. People want to avoid that. And finally, the people that do enforce that, there's enforcement rules around who actually has permission to go out and enforce those breach notifications, and that is the Office of Civil Rights, or the OCR. And those are the people who do the audits. Now, right now, they've pretty much only done the audits when someone has complained and said, hey, I had an issue with this provider, go check them out. But they are moving into the next phase of audits, which is they can come audit you pretty much whenever they want. And they haven't established all the rules behind this yet, but they are now moving into that next phase of you could just get audited. And that's making a lot of people pretty nervous, and they want to get their these big data systems up to snuff. And that's the OCR is also not to be confused with the ONC, just in case you see those two terms. The ONC is actually the office that makes the rules. And then finally, what makes all of this stuff relevant to cloud providers is the omnibus ruling in 2013, which is an extension to HIPAA that defined what a business associate actually is. And a business associate, and you can see what I have highlighted, they've modified that definition to really anyone that maintains or transmits PHI. And this is worth digging into a little bit more. What is a business associate? Well, that's a third party that creates, receives, maintains, or transmits protected health information on behalf of a healthcare provider, clearinghouse, or health plan. Another term for that is covered entity, if you see that. But it really means, since it transmits or maintains, that becomes a cloud provider. And this isn't, again, not unique to AWS. If you go to Google or Azure, we all consider ourselves business associates if you want to store PHI on us. And what that business associate agreement is, it's a legal binding document that says, you want to store PHI on this cloud service? Great. We're going to do these certain things, and we hope that you're going to do, not we hope, we are going to contractually obligate you to doing these other certain things. And so just an example, now the BAAs are going to vary by cloud provider a little bit, but in general, they're after the same sorts of configurations. And first of all, customers, they got to encrypt ePHI in transit and at rest. And so this is what we really enforce this one because this protects you against that breach notification. The breach notification, that's for unsecured PHI. If you have everything encrypted, that could potentially save a lot of headaches for breach notifications. Also on AWS, we require our customers to use EC2 dedicated instances for processing, storing, or transmitting ePHI. And what that means is just because of the way the law has been interpreted, we take a pretty conservative stance on that, which is we don't want to mix potentially other hospital or other patients' data. So if you go up and just take a virtual machine from AWS, you could end up on a host with several other customers. There's an option for dedicated tenancy or dedicated instance, which will say, no, this customer, you're going to be on your own set of hosts, and you're not going to mix VMs with anybody else. Now, we're pretty confident in our hypervisors, and we think eventually the laws might catch up. But for now, we have all of our HIPAA customers on their own host, and that's an option that you choose. And then finally, you have to retain all the use and access to who actually saw that PHI and what did they do with it and all that good stuff. And there's additional talks that you can find by AWS where we get into the very gritty details of what do you actually want to be logging for that third step. So why is this hard with Hadoop? So first of all, everything kind of relies on the traditional data center model for HIPAA and a lot of the enterprise IT in general. And that goes away in the cloud where you have infrastructure as code, you have these ephemeral clusters that are coming up and down and your data stored separately. Also the data protections. So data at rest, there's a transparent data encryption, great feature, and that protects HDFS. But then most of these applications, they're spilling out to disk. And so you end up with a bunch of PHI sitting on disk or in your trash bin. And so what do you do about all that stuff? Also, the data in transit. No matter what application you choose, does a different way. So if you're doing MapReduce applications, well, now you have to worry about HTTPS, how to distribute all the certs to all your mappers, or to all your mappers and your reducers. But then if you're using Spark, now all of a sudden you have to worry about SASL encryption. And so it's just a hodgepodge of different techniques that each of these applications kind of independently chose. There's also authentication. Kerberos is pretty good, but it comes with a bunch of headaches if you've actually tried to do it. And then authorization, again, it's an inconsistent. And then all the monitoring. All these different applications all have their own set of logs, own set of tools. So how do you bring that stuff together? So if you get the ONC comes in and you have to show your logs of who had access to what, you want it in a nice centralized location. And so just because it's a HIPAA cluster, you shouldn't necessarily be giving up a lot of the ease or have a bunch of extra complexity for your analysts or your developers. You want to take that away from them. And so before I hand off to John, as he starts going through a lot of the techniques you could be thinking about and best practices for having a secure in the cloud cluster, the thing you want to keep in the back of your mind is that it's different in the cloud. It's not, you don't want to think about it as, okay, I have my big cluster coming in, like an old enterprise, like an enterprise data warehouse, where I have, I'm going to protect it at that level and have all these users come in. You actually want to use the controls of the cloud to protect the cloud itself. You want to kind of take up at a level beyond the cluster and say, I have this cluster, it's up in, who can actually start a cluster? Who can actually look at what data? Use the controls of the cloud to say, this person only has access to this pieces of the data, as opposed to thinking about it as who can come into my cluster and do what. And so with that in the back of your mind, I'm going to turn over to John, who can get into some of the specifics around best practices for doing that.
Cool. Thanks, Chris. I'm John. I'm the Senior PM for Amazon EMR. And Chris already went through a little bit about EMR. Happy to talk more after the presentation about it. But I think we should jump into a little bit more of how to go do some of the things that Chris talked about requirements that are needed to secure data. A few things on how actually to do it, things that you should think about when setting up a cluster and understanding it. In EMR, we actually configure a lot of this for you automatically. But still, it's a good idea to know exactly what's going on and be able to explain it and own those configurations. So, typically when you think about securing the cluster, there's a few different buckets you can put things in. The first, obviously, is encryption. As Chris noted, you need things encrypted at rest and encrypted in flight. And then the questions are, what are your different data layers? Who's transferring data? Where are your keys? What keys do you want to use? And a lot of that just depends on your security requirements and how you're actually implementing your big data environment. But also, there's a lot of just other general security things. You need to, as Chris put, secure your network, but you also need permissions. Who are your users in your cloud environment? What permissions do they have? And AWS has a lot of tools to make this easy to use. But those are things that you're going to need to consider when building out your environment. And finally, just at a compliance level, you need a way to figure out who's doing what, being able to audit it, replay things, and figure out exactly who's interacting with your environment and what they're doing. So, one thing of any EMR presentation you hear about, we talk a lot about S3 as your data layer, and Chris already mentioned some of the pros of using S3. Designed for 11 nines of durability, dissociate your storage and your compute, save costs, easy to manage, and all of that stuff. So I won't repeat all of it. But typically, when you think about your data encryption at rest, the first thing to think about is where you're storing your data, and oftentimes that's S3. But even before you think about Hadoop, you have a lot of processes that are pushing data to S3 anyway. So that's when you need to start thinking about encryption. Isn't, hey, I've got a MapReduce job or I've got a Spark job that's reading. It's, I've got a bunch of clients living somewhere pushing data into S3 to begin with. So S3 supports two types of encryption, two modes, I guess, server side and client side. They both use AES-256. We see a lot of both. And basically, you have in the SDK, you have the S3 client and the S3 encryption client. Server-side encryption uses the S3 client, and basically S3 is managing the encryption and the cycles on the S3 server side. And you have two options for keys. You can have S3 manage the key, and basically when you put an object, there's just a flag in the put call. You say, hey, use S3 server-side encryption with S3 keys, and S3 manages that encryption. You can also use the AWS Key Management Service, which is a service we have that allows you to create keys and use them in the AWS environment. You can rotate keys, you can turn off keys. When using server-side encryption, you can have S3 use those keys instead. And that gives you a little bit more granularity and control. And you can put permissions on those keys as well as the S3 object to give you that granularity. There's also SSE-C, which is you give S3 a random key that you want to use, although we don't see that as popular as if you're using your own custom keys and say an HSM, you're probably going to be using client-side encryption. So client-side encryption, you utilize the S3 encryption client to push objects. Both are using envelope encryption as well, using your key to basically encrypt a data key that's individual for each object that you store in S3. And in that case, you provide a class, an encryption materials provider, which is basically the logic that the S3 client knows how to reach out and go get whatever key you want to use from the location. You can also do client-side encryption with keys in AWS KMS as well. And as I said, it really depends on how, typically requirements around how you want to manage keys. We see a lot of both. In EMR, so you put your data into S3 and now it's sitting there encrypted either with server-side encryption or client-side encryption. Now you come to your Hadoop cluster that you've spun up, and your application that's running in that cluster wants to read it. You want that to be transparent to the application. That's typically pushed down into the S3 connector. There's a bunch of S3 connectors out there. There's S3A, which is the replacement for S3N. In EMR, we actually have our own connector, EMRFS, and that actually transparently handles all this encryption. You basically just tell EMR, hey, here's my encryption materials provider to use for client-side encryption. Take care of it. And from a Spark application layer, it has no idea what's going on. But in EMRFS, it's handling with decent performance the encryption on the client side, or talks to S3 in a way that it can enable server-side encryption as well. So great. So you've encrypted everything in S3. You've read it in, and now you have two more file systems you have to worry about encrypting: your local file system and HDFS. In the EMR world, we install HDFS on all clusters. It's useful even if you're not storing data long-term in HDFS, because things like Hive, in between each MapReduce job, if you're still using Hive and MapReduce, writing out intermediates to HDFS, or you might be storing other intermediates there as well. In your local file system, executors are spilling to temp directories and local mappers are spilling to temp directories. Tez has spills as well. So you need to basically encrypt all of that. So from a local file system, you're running Linux, you can use Lux. In the case of EMR, you could use bootstraps or other things to provision those. You can use also encrypted EBS volumes if you're using EBS. And then for HDFS, you can use the HDFS transparent data encryption feature, which is the open source feature set. I think it arrived at around Hadoop 2.6. And that actually uses keys that are stored on the cluster in either the Hadoop KMS, which is a process that uses the JEX key store underneath it, or if you're running Ranger, you can use the Ranger KMS, which is a similar implementation but has a few more features involved. Just a quick look at HDFS TDE. It uses a similar envelope encryption idea of, you have your key encryption key that's encrypting data keys per file. In this case, you specify your HDFS encryption zone. Actually, one other thing to mention is this is happening in the client. So in-transit encryption for HDFS, like HDFS is rebalancing, or if you're connecting to a remote data node, it's all happening in the client, so things are going encrypted over the wire. So that actual communication you don't need to encrypt because the object is encrypted before it's actually sent. But HDFS encryption zones, you basically set a zone like /temp or /myhive data, whatever, and it creates a key for that zone, and that's the encryption zone key. Each file has a unique data key, and basically you use the encryption zone key to encrypt that data key, and then that's put with the file. And that's kind of an overall thing on how that works. So once you've encrypted S3, your local file system, and HDFS, now you have to worry about encrypting things in flight. So from S3 to the EC2 instances that make up your cluster, that's easy. That's using SSL by default. But then you have to worry about internode transit for data in the application stack that you're running. And that actually differs depending on what framework you're running. With Hadoop, there's encrypted shuffle, it uses SSL. You have to worry about getting the certificate to each node, although you can just drop it in. In EMR, we have a bootstrap action, which is just an arbitrary script that you can run that can just copy it to each node in our case, but depending on the stack you're running, there are different ways to get it on. For Spark, it uses SASL encryption with digest MD5. It's a weaker encryption than SSL. We're hoping that we can work with the community to make that a stronger encryption algorithm, but it's still encrypted over the wire. And then for HDFS data transfer, if you're using HDFS TDE, that's taken care of because it's encrypted client side. But if you don't, and say you just encrypt local file system and the blocks that HDFS are writing are encrypted at the Linux layer, you can just enable wire encryption for HDFS with settings in HDFS site and core site, I think. Now, all these settings that I'm talking about are all configurable via the configuration files for these applications as well. So these are all at the framework level, just open source encryption that's included in these apps. So talking about access control, it's a little bit different than on-prem, as Chris brought up. You're not just securing users who are logging in, but in fact, users who want to process data with Apache frameworks, almost creating the cluster and having that as the unit of the job, as I created a cluster, it runs this job and shut it down, is a way of doing things as well. So you're not only controlling people who log in and say, are submitting Hive jobs through Hive Server 2, you have users who are coming in and creating actual full clusters and you need to control the permissions on what that cluster can do on behalf of users, and even what the guy creating the cluster in the first place can even create it. So there's a lot of different access control levers to pull when you're thinking about securing a cloud environment. So I guess at the user level in AWS, actually in AWS we have many features under the Identity and Access Management (IAM) feature set. And the first is, you need to just create users in your cloud environment in the first place. So in AWS we have IAM users, which basically is an account, AWS account holder. I can create a bunch of users. Each user has a bunch of permissions on what AWS services they can and can't use, and even more granular on, you can use this service, but in this way. Like for instance, you can only access S3 data in this bucket. So very granular levers you can pull, and you can also have these IAM users be basically federated from an Active Directory. You can create them yourself. You can use single sign-on. There's a bunch of different ways to basically allow your users to then adopt permissions when they come into a cloud environment. The next thing to think about, just kind of at a general cloud level, is your network. You launch clusters or EC2 instances in a VPC, a virtual private cloud, which is an isolated area of the AWS fabric. And when you have your VPC, you create subnets, either a public subnet that has an internet gateway, so resources in that subnet can communicate out to public endpoints, or a private subnet, which is locked down and nothing can communicate out of that subnet. It's basically isolated. We've seen typically customers who have high security requirements using private subnets. From the EMR landscape, we started supporting launching clusters and private subnets around December. So as you can see here, there's also, when you have the EC2 nodes in that endpoint, and say you have data in S3, you need a way for a cluster in a private subnet to communicate with the S3 endpoint. S3 actually offers an endpoint in VPC that you can configure so that basically the traffic from those EC2 nodes is never really leaving that private subnet. It's just going directly to that endpoint. But you can also configure a NAT. We now have a managed NAT service where you can have your cluster nodes communicate out with public endpoints for AWS services securely, or do whatever you need to go do. Another thing that's an important thing to note about network security is utilizing security groups. Security groups are basically firewall rules for the EC2 instances that make up your cluster. You can configure them to basically lock down access to certain IPs or whatever you need. In the EMR case, we actually turn everything off except for port 22 to SSH. And we distribute SSH keys, so that's a way for an admin to go access it before setting up more granular rules. So zooming out from just the network level now to the cluster level, how do you limit the permissions of the actual nodes of your cluster? What other AWS cloud services can that cluster access? A good example would be a mapper on an EC2 node needs to access data in S3. So EC2 is needing to have the credentials on your behalf to go access an S3 bucket to be able to get the data. So that's where IAM roles come in. So you assign an IAM role to an AWS resource, in this case EC2, and we call it an instance profile, that has a policy that determines what the EC2 instance can and can't do on your behalf. So for instance, you can have a policy that says you can't access these S3 buckets, you can access these S3 buckets. If you say you wanted to use Hive to write out to DynamoDB, you need access, you need to give permissions to that EC2 instance to be able to call the DynamoDB API on your behalf. So it's a way to really lock down the permissions of, at a cluster level, what can that cluster do, what can that cluster not do. I bring up the service role here for folks who are using managed services, EMR as an example. You also have now the service as well that you might want to lock down the permissions for, and that's where you can give an IAM role to, say, the EMR service, saying, hey, EMR service, you can create EC2 instances to create the cluster. Otherwise, the EMR service wouldn't have any permissions to do anything. So it's another way to lock down services that are doing things on your behalf as well that might manage your cluster. So both of those are available. But then zooming into the actual cluster, if you have multiple people logging in, and this is just general open source auth features for Hadoop, you can easily enable Kerberos. In this case, actually, you can use a bunch of scripts to get it working. There are a bunch of different ways. In the EMR world, actually, we're going to be writing a big data blog. And if for those of you who do not know the AWS Big Data blog, I highly recommend checking it out. Tons of interesting examples, customer stories, tutorials, and things to quickly just play around with a lot of the AWS Big Data stack. But we'll be writing just a quick thing on how to, in a couple clicks, just enable Kerberos on your cluster and link it to an AD. But obviously a very useful thing to give users identity when they log in and limit what things they can and can't do. Another thing is just if you have a centralized access point, like say Hive Server 2 or Hue, which is the open source UI for a lot of these query tools, you can use, just link it with LDAP, your Active Directory, so when those users log in, they have certain permissions. Fine-grained access controls, Hive Server 2 supports views and tables, HBase has cell-level control. If you choose to install something like Ranger or Sentry, they have a little bit finer-grained control. Ranger, you can do, say, column-level control in Hive. A bunch of plugins for different projects that are supported by those two. And actually, on the Big Data blog, you can also install Ranger via Bootstrap on EMR, and we'll show you how to do that. But if you want to know now, we can talk after the presentation. But there's also some great third-party services as well, Blue Talon, Data Guys, and these actually, and more. But these actually support also data masking, which when you talk about, as Chris mentioned, PHI data that you might want to obfuscate, so it's not really under the same scrutiny, you can use these tools to do that as well. So, and I think some of them are actually out in the vendor area, and I highly encourage you to go chat with them. Finally, to close, monitoring and auditing. You want to make sure that you can track what's going on. And there's a few tools that are available for clusters in AWS. The first is AWS CloudTrail. So as I mentioned, you have these EC2 instances that might be talking to S3, talking to Dynamo. You might have a user that's interacting with the AWS resources at the cluster level. Via API, CloudTrail tracks all of this and writes it out to S3, and you can then dump it into something like Elasticsearch. AWS has an Elasticsearch service that you could use. You could roll your own. All of that is available for you to dissect and monitor. You can put it into Splunk. There's a lot of different things that we see customers doing, but it's a good way to track who's doing what with your AWS environment and when. But if you want to get even more granular, you have clusters that are accessing data in S3. You can use the S3 access logs to audit this at a per object level as well. And with EMR, actually, you can even inject in the cluster ID and the Yarn application ID that has been writing those as well. So if you want to get granular to see where did this come from, who last touched this object, what was the Yarn app that was doing that. There's also just audit logging in the open source apps. A lot of logs are generated. EMR, we push them to S3, but you can also get them on probably whatever distribution you're running, in HDFS, wherever they're being written. Ranger and Sentry also have logs based on the policy generators and actions that are happening as well. So lots of information you can dissect. And then finally, just using Ganglia or AWS CloudWatch or general monitoring tools, it's good to keep an eye, not just for performance tuning reasons, but just to see how many jobs are active, and maybe it could clue you in on things that are happening that you might want to take a look into. So, in conclusion, security is critical for an environment, especially for HIPAA workloads and PHI information. AWS, we have a lot of tools to make that easier, no matter what distribution you're running. The goal is just we want you to iterate fast, but stay safe while you're doing it. So anyway, thanks a lot. Feel free to email me or Chris if you have any questions. I guess, do we have time to take one question now? Yeah, we'll take one question. Thanks. Yes.
So, in order to qualify for HIPAA certification, you said that the EMR instances need to be dedicated. Okay. But then, like S3 storage is not dedicated, so there seems to be a conflict there as to.
It has to do with the
resources are required and when they're not.
So the dedicated tenancy, that's specific to EC2. So the EMR service, it runs on EC2, and it has to do with the VM. So in S3, we're confident enough in the way that we have separate encryptions and separate mechanisms for keeping all that data separate that we just say, we're confident we're going to take ownership of that, and you don't have to worry about that it's a mixed tenant, because we have our controls in place to make sure that no customer data gets mixed. Whereas if we're working in the host world, specifically in the VM world, it relies on that hypervisor. And so in that case, we say we don't quite mix the data at the hypervisor level. And so that's what it has to do with.
OK, thanks.